For this station activity, we are going to be working on Station 4, which will be over Topographic Maps. So you're going to click the link for your practice assignment and select the Make a Copy option so that you can edit the document. So this is the assignment, and what we're going to do is assess our knowledge on how topographic maps and satellite views are used to identify land and erosional features. So we're going to place only the cards with accurate information in the correct location on the chart. We will then use the symbols on the correct cards and the legend to the right to decipher the code. So this assignment might take you a little bit more time because we need to look at each one of the cards outlined in red and determine if they are correct or not. Okay, so the contour interval is how much each line on a topographic map changes by. So if I enlarge this image so we can look more clearly at the contour interval, we need to calculate how much each line is changing by. So here we have 0 meters, which is sea level, and then it skips a line and goes to 20 meters. So that informs me that this interval is increasing by 10. We go from 0 to 10 meters to 20 meters, and then the next line would be 30 meters. So this card is accurate. And I'm going to put that here because so far it's right. But I do want to double check and make sure that I'm not making any mistakes. So I'm going to look at this contour interval card. I'm going to enlarge that. And it's saying that the contour interval is 20. So let's look at our lines. The first line is 10 meters. So if it were 20, then we would add 20 to 10. So this next line, right after 10 meters, should be 30. But they have 30 listed here. So the contour interval can't be 20. It has to be 10. Because if this is 10 meters, then this would be 20, and then this would be 30, as they have it labeled. If it were truly 20, the second line, right after 10, would be labeled as 30 meters. So this is incorrect. So we don't want this card. And you will just go through each of the contour intervals and check them. Okay, so we're done with those. You're also going to have to check to see if the elevation of each of these examples is right, and the one that is correct will go here in the box. We have difference in elevation, so what that would be doing is determining what the change in elevation is between X and Y. So here it's saying that the difference is 20 meters from X to Y. And so I'm going to look around. This is 0 meters and this line is 20. So I think my contour interval is 10. 0, 10, 20. So Y has an elevation of 10 meters. Okay, and then the very next line would be 20, and the very next line would be 30. So X has an elevation of 30 meters. 30 meters minus Y's elevation of 10 meters gives me a difference of 20. So I got lucky and the first one I tried happened to be correct. I identified the correct elevation for this scenario. So you would just need to double check the other two just to ensure that you're doing it right. Plus it's extra practice, which never hurt anybody. And then the last category is slope. So you're just going to enlarge and we're going to look at slope. So we have gentle or gradual slopes, and then we have steep slopes. And what you need to remember is the closer together our contour lines, like the east side of this map, would represent a steep slope. And the furthest apart lines would represent a gentle or gradual slope. So you'll go through each of those three scenarios and find the one that is accurate and put it into our table. Once you've done that, you'll match the symbol with the letters in the legend and record the information onto your activity sheet. And it's important that you check out the extension so you get some exposure to satellite.